Hello guys, so welcome to another video of Maths with Mas. So today we're going to study vectors, and vectors is a very interesting topic, let's be honest, and we're gonna study it in a very simple way and in portions basically. Like, I'm not going to teach you maths A level vector today because that's too complicated for to start with. I'm gonna teach you the basics of vectors first. Okay, so let's begin. So first of all, we need to know what a vector is. If you studied physics, you would know that a vector is basically something that has direction and a unit. Okay, so unit, sorry, not a unit, direction and magnitude basically. Okay, magnitude and direction. Okay, that is what a vector is. And in this course we will be studying 3D vectors too. So what are 3D vectors? First we need to understand what a dimension is. Three-dimensional vectors, right? So what a dimension is? A dimension is basically where mutually perpendicular lines intersect. For example, this is 2-dimension because two mutually perpendicular lines intersect. But if I make another third dimension, that would become, if this is here, this is perpendicular to this and this as well, because like it's 3D, I can't represent it on a paper. But if I do it that way, then it's like the z-axis. If in the real world, if you see a corner, basically a corner is like this, right? It has one line coming from here, one over here, one over here. Now this is the line that is coming from outside. Actually, I now can't draw it actually, but you get the idea, right? Okay, so we know what a dimension is and what a vector is, and there is one basic rule in this vectors chapter that you need to know, and that basically solves all the basic questions. So, but first of all, we need to know what how to represent vectors. So the vectors could be represented in this way. Let's say I write 4 3 2. This is a column vector basically. Okay, and this could also be written as 4i plus 3j plus 2k. So this is the value of x, this is the value of y, and this is the value of z. On a plane, it could be like if we move from 0 0, this is the third axis. Okay, so if we move from 0 0, we go 4 units in the direction of x, in the positive x. Okay, then we go 3 units upwards in the direction of y, in the positive y, and then we go 2 units outside or inside, that depends, and that is our point. And this could be determined in a way that if we have a point in a 3D world, like around you there's a point in air, this is a room. Okay, this is a point in air, so there would be a shadow underneath this point. Okay, so first we need to track the axis, like the x and the y. This is the x, this is the y, then you go upwards to the shadow, and that is the z. Okay, now you get the idea. Okay, so if you have any sort of questions, feel free to ask me in the comment section. So this is basically a column vector, and this representation of the vector is basically another representation of how to like write a vector. And the I represents the x coordinate, the j represents the y coordinate, and the k represents the z coordinate. Okay, so that was it for the introduction of vectors. So let's now do the formula that we need to know, and that would be it for this video, because this I'm just teaching you the basics, the very basics of vectors, and the real vectors in the math analysis and approaches course would begin later. So now after this we'll do some questions on vectors to enhance your understanding of 3D vectors and also your practice. Then we'll move to the advanced part. Okay, so um, the rule over here is scalar product. So what is that? So have you ever seen two vectors being multiplied, two vectors being multiplied and the answer being a scalar? Like vector times vector is equal to a scalar. A simple example of this is, if you have studied physics, that is the formula for work done is force times displacement, and that is displacement in the direction of the applied force. So this is a vector, this is a vector, but work is a scalar product. Okay, so how do we calculate a scalar product? That is like the basic representation of it, right? When you have the magnitude of force like 20 newtons and you have the magnitude of distance that 5 meters, then you can calculate the magnitude of work, then that is 100 joules. Okay, but what if we have vectors? Then what do we have to do? So let's say that we have a vector OB that is 4 3 2, and then we have, I don't know why there is that obsession with the numbers 4 3 and 2. Anyways, oh, by the way, the vector is written like this with the arrow above it. Then we have OA, which is written as, which is equal to 1 1 1, just for simplicity reasons. Okay, so first we need to calculate OB times OA. Now this times this small dot, this is used when we need to calculate a scalar product, which means that when we are multiplying two vectors, we use a dot. Okay, I'm sorry, I forget the arrows every time. So how do we calculate a product of these two vectors, 4 3 2 and 1 1 1? So that is simple. That is 4 times 1 plus 3 times 1 plus 2 times 1. 2 times 1, and that would be, what would it be? 4 times 1, 4 plus 3 plus 2, that would be 9. Okay, that is the product of these two vectors. Okay, and now let's move to the magnitude. Okay, that is basically the product of vectors. Let's just write a formula over here. That product rule would be OB times OA. It would be x times x, basically the x of the both, plus y times y. Now you can write 1 2, because that way it would become x square and y square. Y1 times y2, and plus z1 times z2, and that would be it. Okay, that is the scalar product. Now let's see the magnitudes. So the magnitude also has a formula, and that is, you just square the thing. Like first, let's calculate the magnitude of OB. Magnitude is written like this with the modulo sign, basically, because magnitude is always positive. You can't, a length can never be negative, right? So it is square root 4 square plus 3 square plus 2 square. It's basically just like the Pythagoras theorem, and that, which is that if it is a b c, right? So if it is c square equals to a square plus b square, so if we have to calculate c, then it would become a square plus b square on whole under root. But this, in here we have three sides, x y and z, so we write 4 3 2, we add them all basically. So that way we'll get the magnitude of OB, and that would be 16 plus 9 25 plus 4 29, so 29. Okay, and next we need to know one more thing, and that is angle between the two vectors. So the formula for angle between two vectors is cos theta is equal to, the cos theta is the angle between the two vectors. Let's say I have to calculate the angle between OA and OB, right? So it would be OA times OB, that is the scalar product we just calculated. That would be the scalar product of these two over OA, the magnitude, multiplied by OB, the magnitude, like the scalar product of both divided by the magnitude of both multiplied. Okay, so if we calculate this, we got this one as 9. This is square root 29 times the magnitude of a, that would be, that is simple, square root 1 square plus 1 square plus 1 square. That would be 1 plus 1 3, square root 3. Okay, so it would become square root 3. So cos theta is equal to 9 over 29 times 3. What is 29 times 3? That is 60. And then let's just do it over here. Okay, 3 times 9 7, 2, 3 times 2 6, 7 8. Okay, 87. I just like forget what I write. The writing, like this fabulous handwriting I have. Okay, so this is the denominator, and then we will just do cos theta is equal to cos inverse this entire thing. I'm not writing that again. Okay, and that is it for the scalar product. And yeah, if what if, like, if a question asks us if that the both lines are perpendicular to each other, like both vectors are perpendicular to each other, that way what is the angle, the perpendicular angle, that is 90, right? So cos theta would be cos 90, and if you have studied graphs, cos 90 is always 0. Okay, so it would become 0. And if 0 is equal to OA times OB over OA OB, that would be only the sum of this OB. So it would be OA times OB, basically scalar product, equal to 0. And if that is the case, then the two vectors are perpendicular to each other. Okay, and in the case of parallel vectors, the angle between them is 0 degrees. So cos 0 is equal to 1, and then this entire thing would be equal to 1. Okay, that is it for the video. Thank you for watching.